So usually, when we talk about evaluating technical systems, there's this expectation of, observable mechanics.
Right, like looking at the back end.
Exactly. You look at a database schema or you measure query latency, check the load balancer metrics, and you have this clear, quantifiable map of what's happening. You can point to a bottleneck in the architecture and just say, there it is, that's our constraint.
Yeah, it's highly legible. I mean, we're trained to look for friction in the server architecture or, the data pipelines. We really like our technical problems to be neatly categorized in log files.
We do. We spend all this time analyzing the engine, but we rarely apply that same level of rigorous structural analysis to the steering wheel.
That's a great way to put it.
Thanks. I want you, the listener, to just take a second and think about the digital interfaces you interact with every single day. The heavy-duty enterprise software, the cloud dashboards, configuration
The
screens.
stuff you use for work, basically.
Right. When you get to the bottom of a really complex configuration form and you need to commit to a choice like toggling a feature on or off, where do you expect that little interactive control to be?
Well, you anticipate its location based on a deeply ingrained, almost completely subconscious mental model.
Yeah.
Your motor cortex actually initiates the movement of your mouse or your finger on a screen
Mm.
before you've even consciously processed the text next to it. It's,
Yeah.
it's an interaction that is entirely invisible when it works.
And it becomes just glaringly obvious when the architecture fundamentally betrays that mental model.
Oh, absolutely. It's jarring.
So that's what we're doing today. We are digging into the mechanics of that betrayal. We're doing a deep dive into the UI and UX architecture and the standardization protocols for this highly mature piece of professional accounting software called osFinancials.
And its counterpart, TurboCASH,
Yes, TurboCASH as well. And we are specifically analyzing this massive architectural shift that occurs in version 5.1.0.269.
which I know looking at a specific version update of a legacy accounting suite might seem incredibly granular, like really in the weeds.
Not in the weeds.
But this analysis serves as a masterclass in the cascading consequences of technical debt. We are looking at how a seemingly microscopic UI decision, literally just moving a box, behaves like a localized gravitational anomaly.
It just warps everything around it.
Exactly. Everything.
So the mission of this deep dive is to explore how the spatial positioning of a single checkbox dictates international localization constraints, alters cognitive load based on human biomechanics, exposes decades of buried architectural debt, and ultimately rewrites the grammatical syntax of 105 distinct languages.
Yeah, in complex software environments, the pixel is never just a pixel. It's a structural load-bearing element.
So whether you're an engineer pushing code, a product manager mapping user journeys, or just a professional navigating dense software environments every day, this is going to fundamentally reorient how you perceive user interfaces.
We're pulling back the curtain on the massive hidden machinery operating behind the absolute simplest selection controls.
So let's trace this back to the architectural foundation of osFinancials. This system carries really deep legacy roots. It inherited structural and design paradigms from earlier iterations, notably TurboCASH H3.
Right, it's been around for a while.
Yeah, and analyzing the transition to version 5.1 exposes this glaring inconsistency that just sort of emerged from these archaeological layers of code. The system suffers from what we'd call a split-brain user interface.
And that split-brain paradigm is a textbook manifestation of technical debt.
How so?
Well, when software evolves over multiple decades, you have different engineering teams utilizing different frameworks, operating under totally different design philosophies across different eras, and they leave structural artifacts behind.
Like digital fossils.
Exactly like digital fossils.
Yeah.
In osFinancials, this friction surfaces most aggressively in the handling of selection controls. So you have radio buttons, which are mutually exclusive selection arrays, and those are positioned correctly on the left margin.
Okay.
They act as the leading element before the text label.
Which is the standard expected layout, right? Control first, description second.
Right. But then you navigate to the heavy data entry environments within that exact same software. Areas like the batch advanced configuration or the stock setup parameters,
Those really dense screens.
the super dense administrative screens. And in those environments, the Boolean controls, the checkboxes, are detached from the left margin and anchored to the far right.
Oh, wow.
Yeah. The descriptive text label leads on the left, and the interactive control trails all the way on the right.
So you have a user configuring this complex accounting ledger, and they're encountering radio buttons anchored on the left, but checkboxes floating on the right.
Right. It's a mess.
This isn't just an aesthetic quirk, right? It actively fights against human cognitive processing.
It absolutely does.
Yeah.
It violates the core principle of affordance.
Okay, break that down for us. What is affordance?
So, affordance dictates that the visual and spatial properties of a control must immediately communicate its function and its readiness for interaction. When an interactive element like a checkbox leads a line of text on the left margin, it acts as an immediate visual prompt.
Got it. It establishes upfront that the following information is actionable.
Exactly. It sets the context before the user even reads the words.
But reversing that sequence, placing the descriptive text first and isolating the control at the end of the line, that triggers a specific cognitive pattern, doesn't it? The source material calls it the exam mark psychology.
Yes, the exam mark psychology.
Yeah.
Because that is exactly the mental model it triggers.
It immediately evokes the feeling of filling out a bureaucratic form or like taking a standardized test in high school.
Right. You parse a statement, and at the absolute end of the horizontal line, you encounter a space for a mark or a signature. The label leading the control implies a process of verification or retroactive review rather than a primary proactive input choice.
So the user ceases to be a driver selecting a preference, they just become an auditor signing off on a completed statement.
Exactly. The spatial positioning fundamentally alters the psychological weight and context of the interaction.
But the friction goes a lot further than just cognitive context. Anchoring these controls to the right margin introduces severe biomechanical inefficiency. And we have to look at this through the lens of Fitts' law, right?
We do. Fitts' law provides the mathematical foundation for human-computer interaction.
Okay.
It basically models the time required to rapidly move to a target area. It's a function of the ratio between the distance to the target and the width of the target.
Okay, so a left-aligned stack of checkboxes optimizes Fitts' law perfectly then.
Perfectly. It creates a highly predictable, uniformly distributed vertical vector. The user's cursor simply descends the y-axis. The horizontal distance traveled, the x-axis delta, is effectively 0.
Right, you're just moving straight down.
Exactly, straight down. The time to acquire each subsequent target is totally minimized.
Now contrast that with the legacy osFinancials layout. When those controls are anchored to the right of the text labels, the layout completely shatters that vertical predictability.
Because text strings have highly variable lengths.
Exactly. One parameter description is 30 characters long, the next is 15, the next is 45. If the interactive control trails immediately after those variable strings, the predictable vertical column turns into a randomized scatter plot on the right side of the screen.
A complete scatter plot. The user is forced into continuous micro-adjustments along the x-axis for every single Boolean choice.
Right.
The motor cortex has to calculate a totally unique distance vector for every single click. That drastically increases the time to acquire the target, and it genuinely induces physical fatigue.
Over hundreds of clicks, absolutely.
And furthermore, radio buttons and checkboxes are functional cousins. They both mediate state selection. Forcing a user to operate in two entirely disjointed spatial paradigms, depending on which specific Boolean control they are interacting with, is, well, it's the very definition of interface friction.
I mean, think about this in the context of physical hardware design. Imagine stepping into the cockpit of a car where the primary steering wheel is exactly where you expect it to be, right in front of you.
Sure.
But then the manufacturer decided to mount the turn signal stalk on the passenger side door panel.
That would be maddening.
Right. The driver's intent is perfectly clear, but the interface architecture requires this disruptive, totally unnatural physical extension just to execute a standard operation.
Their flow is constantly broken.
Exactly. You aren't just operating the vehicle anymore, you are actively managing the interface friction. An accountant processing hundreds of batch journal entries in osFinancials is experiencing that exact same biomechanical tax. They are fighting the interface for every data point.
It's exhausting.
Which raises the inevitable question. No engineering team sets out to build an actively hostile interface. So why on earth was this right-aligned architecture deployed in the first place?
Well, to understand that, we really have to contextualize the era of early software development and the tooling that was available at the time. Legacy desktop applications were frequently engineered in a vacuum.
Meaning what, exactly?
Meaning they were often localized to a single language, typically English,
Yeah.
and targeted at a very specific regional market.
Okay.
When you are developing a monolithic application for a single linguistic demographic, developers can manually define the physical coordinates of UI elements. They can achieve a visually balanced, rigid layout.
But that architecture fails completely the moment you try to scale that software globally, doesn't it?
Oh, it falls apart instantly.
And the scale of osFinancials' global footprint is just immense. We're looking at a system architected to support 105 distinct languages.
105. That is a massive localization matrix.
It encompasses everything from Afrikaans.dfm and Arabic.dfm through specific regional variants like English for Zimbabwe or French for Vanuatu, all the way down to Xhosa.dfm and Zulu.dfm.
And those .dfm files, the Delphi form files, they are the architectural anchor of this entire problem.
Tell me more about that.
Well, early rapid application development environments, like Delphi, relied heavily on absolute positioning.
Okay.
So the engineering team hard-coded the exact X and Y pixel coordinates for the text label. And then they hard-coded a completely separate set of X and Y coordinates for the checkbox.
So that absolute positioning just assumes the UI is a static painting. It assumes the length of a word is a universal constant.
Which completely ignores the reality of localization engineering.
Right.
Translating a user interface is never a one-to-one character exchange.
Right.
Localization teams operate on a standard metric known as the expansion factor.
Okay, what is the expansion factor in this context?
Basically, when porting an interface from English to another language, the UI container usually have to accommodate a 30% to 50% expansion in the physical pixel width of the text string.
Wow, up to 50%.
Easily. Because English is a remarkably compact language for technical interfaces. Take a standard parameter label like use barcode. It's terse, it fits neatly into a tight column.
Yeah.
But you hand that string to the German localization team, and it returns as Barcodeleser verwenden.
Oh, wow.
Right.
Yeah.
That is an immediate 60% expansion in character volume and physical pixel footprint.
And the architectural strain becomes even more severe with agglutinative languages, right? Like Xhosa or Zulu, which construct complex meaning by compounding multiple morphemes into these massive single words.
Exactly. A hard-coded layout simply cannot absorb that kind of physical expansion.
Let's actually trace the execution path of that. So an engineer codes an English configuration screen. They drop the use barcode label at a specific coordinate, and they anchor the checkbox a few pixels to the right.
Yep. Looks perfect in English.
Then the German.dfm file is loaded into the compiler. The text string expands by 60%. The UI layer just breaks.
It completely breaks. The result is this aggressive UI failure state called the overlap.
The overlap.
Because the text label is locked to its origin coordinate and expands outward along the x-axis, it physically collides with and overwrites the trailing checkbox.
It just types right over it.
Right over it.
Yeah.
The interactive control is buried under the localized text. The application becomes functionally inoperable for that region because you can't click the box.
So to avoid refactoring the entire layout engine, the legacy developers deployed this widespread structural patch. They introduced a secondary UI failure state, the canyon.
The canyon. Yeah, it's a great name for it.
To guarantee the localized string would never collide with the control, they detached the checkbox from the text entirely, and they hard-anchored it to the extreme right edge of the application window.
Right. They engineered the layout to accommodate the theoretical maximum width of the most expansive language in the entire localization matrix.
It's just a localized patch for a systemic architectural flaw.
It is.
But wait, this canyon solution introduces massive cognitive friction for the baseline English user. I mean, if the gap is so huge, doesn't that make the exam mark problem we just talked about even worse?
Oh, it absolutely exacerbates it.
Because the English label remains compact on the far left, the interactive control is anchored hundreds of pixels away on the far right. The user is presented with a vast, unstructured void between the description and the action.
The visual tether is just completely severed. The user has to read the parameter on the left margin, track their eye across a desert of negative space, and attempt to maintain the vertical alignment perfectly to ensure they are interacting with the correct control on the right margin.
So the human brain is forced to manually relink the known to the Boolean action.
Yes.
And from an engineering perspective, managing this has to be a nightmare of technical overhead. You have a localization engineer manually adjusting the x-axis offset of checkboxes across hundreds of individual .dfm files,
Adding 10 pixels for Dutch, 30 pixels for French.
It's the definition of unsustainable technical debt. The geometry of human language will always break absolute positioning.
It will. And the osFinancials engineering team recognized this unsustainability. The friction of maintaining 105 bespoke localization layouts mandated a complete architectural review.
Okay, so what did they do?
Well, to establish a resilient framework, they analyzed the UI standardization protocols of industry-leading platforms to identify the universal baseline.
And the consensus is absolute, isn't it? Universal left alignment.
Unanimous.
The interactive control must anchor the left margin, serving as the leading element before the descriptive text. Checkbox, then label text.
Right. And the primary architect of this global standard is Microsoft. Their Office suite basically established the dominant UI paradigm for a whole generation of knowledge workers.
And open-source counterparts like LibreOffice enforce the exact same standard to guarantee cross-platform predictability.
Exactly. And looking at direct competitors in the accounting sector platforms like QuickBooks Online, Xero, Sage Intacct, every single modern cloud architecture has eradicated right-aligned Boolean controls.
They standardize on the left to prioritize visual processing speed and to support responsive mobile-first environments, right?
You cannot deploy a canyon layout on a mobile viewport. The horizontal real estate simply doesn't exist. You'd be scrolling left and right constantly.
But Microsoft's standardization wasn't arbitrary. It was derived from foundational biomechanical research into reading gravity.
Yes, reading gravity. It maps the instinctual visual traversal of a digital interface.
So eye-tracking telemetry consistently demonstrates that users parse dense information architectures in an F-shaped pattern.
Right. Upon rendering a screen, the fovea anchors to the top left origin point. The user executes a rapid horizontal scan across the top, drops down the left margin, executes a shorter horizontal scan, and then commits to anchoring their visual focus exclusively along the left edge, moving downward.
The left margin serves as the foundational anchor point for cognitive processing. We see this in analog mediums too. Like, think about reading a physical book. When you finish a line, your eye doesn't hunt for the start of the next sentence in the middle of the page.
No, it snaps violently back to the left margin.
Exactly. Microsoft simply aligned the most critical interactor elements with the baseline mechanical behavior of the human eye.
Left alignment collapses the visual acquisition loop. The user identifies the parameter and its current Boolean state checked or unchecked in a single unified microsecond down the margin.
There is a notable historical divergence here that we need to address, though, specifically regarding legacy enterprise systems, the SAP exception.
Yes, the SAP exception.
Historically, massive enterprise resource planning environments like the early SAP GUI deployed interfaces where the label was anchored left and the checkbox was pushed to the far right.
They did. But that architecture prioritized rigid tabular gated density over cognitive processing speed. If a configuration screen contained a column of text input fields for dates or currency values, engineers would push Boolean checkboxes to the far right simply to maintain a perfectly flush vertical edge on the right side of the form.
So they sacrificed human-computer interaction efficiency for the aesthetic of a perfect geometric grid.
Exactly. It was purely aesthetic for the back-end developer. But the industry consensus has shifted so radically that even SAP has deprecated that architecture.
Really?
Yeah. Their modern Fiori design system explicitly mandates standardizing Boolean controls on the left margin. Their internal telemetry confirmed that right-aligned controls impose an unacceptable cognitive load. It breaks the user's visual scanning rhythm in those dense data environments.
And what's interesting is that osFinancials didn't even need to look externally to identify the standard. The architectural schism existed within their own code base.
It did. The modern modules within the software, like the Reportman Designer and the spreadsheet components, were already utilizing strict left alignment.
So the newer architecture had already solved the problem. The legacy screens were simply creating an internal UX conflict.
Right, and it highlights the concept of digital DNA.
Digital DNA.
Yeah. Users approach a specialized tool, like an accounting suite, with a foundational UI vocabulary inherited from thousands of hours interacting with modern operating systems and web applications.
So when a legacy interface violates that ingrained DNA, the user doesn't stop to appreciate the historical context of late 90s absolute positioning.
No, of course not. The friction registers purely as a defect. The software just feels antiquated and hostile, regardless of how powerful the underlying accounting engine actually is.
Okay, so relocating the control to the left margin resolves the geometric instability. It aligns with Fitt's law, it satisfies the F-pattern reading gravity, and it eliminates the localized canyon patch.
Yeah.
But the most profound consequence of this spatial repositioning is actually entirely unexpected. Because altering the physical coordinates of the pixel block fundamentally rewrites the grammatical vocabulary of the software itself.
It's wild. This is where layout architecture and computational linguistics collide.
Let's analyze the grammar of the right-aligned canyon layout first. You have the descriptive text, a massive void of negative space, and then the trailing control. Because the visual tether is severed, the text string absolutely requires an explicit action verb.
Right, you are forced to write, use barcode printer, or enable negative stock.
The verb functions as a cognitive bridge. If the interface simply displayed the noun barcode printer, followed by 3 inches of empty space and a checkbox, the interface lacks semantic context.
The user has no way to determine what the Boolean toggle actually executes. The verb is a structural requirement just to compensate for the failed spatial layout.
And those required action verbs are the exact linguistic trigger for the localization failures.
Exactly. The verb forces the German translation to compound into a massive string that breaks the physical UI container.
Wow.
The engineering team is trapped in this feedback loop. The broken layout requires a verb for context, and the verb causes the translation string to overflow the layout.
So by fixing a visual geometry flaw on the screen, the developers actually solved a grammar and copywriting problem.
Yes,
The visual design is literally dictating the syntax of the language.
it totally is. Transitioning to the left-aligned architecture breaks that loop entirely. When the interactive control leads the string checkbox, barcode printer, a linguistic substitution occurs. The UI component itself absorbs the grammatical function of the verb.
Because the empty square bracket universally signifies the action of toggling, enabling, or activating within our modern digital DNA.
Right, and because the control provides the semantic action, the text string is liberated from carrying that grammatical burden.
So the localization team can just strip the verbs out of the source files entirely?
Exactly. Use barcode printer is truncated to just barcode printer. Enable automatic backup becomes automatic backup. Allow negative stock is reduced to negative stock.
Deploying this noun-only syntax yields massive architectural dividends. The character count across the entire UI label matrix drops by 20% to 40% globally.
It's incredible. Resolving a physical coordinate flaw on the x-axis unexpectedly optimized the entire global localization pipeline.
By stripping the verbs, a term like barcode printer and its translated equivalents become compact enough to fit securely within standard UI container across almost all of the 105 languages.
The threat of string overlap is basically mitigated without resorting to bespoke pixel offsets for every single language.
Okay, so the theoretical framework is locked. We have the biomechanical justification, the industry benchmarking, and the linguistic optimization.
Right?
But the challenge is executing this architectural shift within a live legacy.dfm environment. How does the osFinancials engineering team actually code this into a legacy system without breaking everything?
Well, the implementation requires a very strict modular approach to the .dfm properties. The first protocol is establishing the fixed anchor.
The control's origin coordinate becomes immutable.
Right. The x-axis coordinate for the checkbox is hard-coded to a permanent value. For instance, left equals 8 or left equals 10. Regardless of the active localization file, the control is permanently anchored to the left margin.
So the vertical vector required by Fitt's law and the F pattern is permanently guaranteed.
Yes. The second protocol is enabling infinite horizontal expansion. Because the control is anchored on the left, the descriptive string positioned to its right is free to expand outward into the container's negative space.
So the German string can expand by 60% without any risk of colliding with the control.
Exactly.
But wait, the container isn't infinitely wide. An exceptionally long agglutinative string in Xhosa could still breach the far right edge of the application window.
It could, which necessitates the third protocol, the wrap and indent rule.
Wrap and indent.
Okay. To handle extreme string expansion, the engine's word wrap property is toggled to true, forcing the text to flow to a secondary line. However, the visual hierarchy must be strictly maintained. The secondary line must indent to align perfectly with the origin point of the primary text string.
It has to align with the text, not wrap underneath the checkbox itself.
Exactly. If the text wraps under the control, it pollutes the left margin and destroys that clean vertical scanning line. The visual isolation of the Boolean control is totally compromised.
Okay, that makes sense.
And the final protocol addresses accessibility via the focus control property. The framework must programmatically bind the text string to the Boolean control.
So interacting with the bounding box of the text string actually triggers the Boolean state change, expanding the actionable hit area way beyond the microscopic 16 by 16 pixel checkbox.
Right. which is critical for complying with modern accessibility standards, particularly for users operating on touch interfaces or utilizing assistive technologies where precise motor targeting is difficult.
Okay, so the engineering roadmap dictates rolling this out across high-density environments first. The master files for debtors, creditors, and stock configuration.
Yeah, the high traffic areas.
But we have to address the immediate operational impact. An enterprise user with a decade of tenure has developed profound muscle memory mapped to that legacy, right-aligned architecture. Their motor cortex is hardwired to flick the cursor to the far right to engage the allow negative stock parameter.
They do it without thinking.
If a user has been clicking the right side of the screen for 10 years, they are going to be furious on day one of this update. Pushing this update fundamentally breaks their operational flow. How do developers balance modernizing the tool with the risk of completely alienating the people who pay for it?
It's tough. Navigating that user friction is the most volatile aspect of modernizing legacy systems. Upgrading an interface to a highly optimized, mathematically superior standard will still generate immediate hostility because it invalidates established motor patterns.
The user's primary concern isn't Fitz law optimization, it's the sudden disruption of their workflow.
Right. Managing that transition requires an active communication layer within the UI. You deploy temporary, localized tooltips to intercept the user's expected action and guide their attention to the new anchor point.
Okay, tooltips.
And you utilize grouping containers, like visual bounding boxes, to cluster related parameters, helping the visual cortex map the new layout hierarchy rapidly. You have to actively bridge the gap between their legacy muscle memory and the new spatial reality.
But the disruption extends far beyond the immediate motor patterns of the user base. Re-anchoring that single pixel block triggers a massive cascading failure across the organization's institutional knowledge.
It does. We are talking about the staggering hidden cost of UI modernization, documentation debt.
Documentation debt. Enterprise software is supported by a massive infrastructure of technical documentation. User manuals, localized PDF guides, sequential tutorials, internal training wikis, video assets.
Mountains of it. And every single one of those assets was authored, captured, and validated against the legacy right-aligned architecture.
So the moment version 5.1 is deployed to production, thousands of pages of technical documentation are instantly rendered factually incorrect.
Completely obsolete in a single commit.
A localized manual explicitly instructing a user to locate the use barcode parameter and interact with the control on the far right is now an active trap.
Right.
A new user following that documentation will encounter an empty void on the right margin and immediately escalate the failure to the support queue.
And the volume of support tickets will scale linearly with the inaccuracy of the documentation.
Well,
But completely auditing and rewriting a decade's worth of technical manuals across 105 languages.
it's impossible.
It's computationally and financially impossible to execute alongside a software release cycle. The engineering team has to deploy a strategic triage plan for the documentation debt.
So how do you mitigate the fallout without stalling the entire release pipeline?
The immediate mitigation relies on a targeted release note strategy. You isolate the architectural change into a highly visible what's new dispatch. You explicitly document the standardization of the left-aligned architecture, and you provide the technical rationale consistency, F-pattern optimization, and global localization support.
You preempt the confusion by explicitly naming the disruption. Don't hide it.
Exactly. And you bridge the cognitive gap using comparative visuals. Placing a screenshot of the legacy right-aligned canyon layout directly adjacent to the modernized left-aligned layout provides an immediate visual translation key for the user's mental model.
Okay, that handles the immediate release shock, but the underlying documentation still needs to be refactored.
It does. And the long-term architectural fix requires retraining the technical writing teams to utilize action-focused writing.
Action-focused writing, what's the core directive there?
The absolute elimination of positional language in documentation.
Because positional language is inherently fragile.
Exactly. Sorry, to be precise, positional language binds the documentation to a specific temporary UI state.
Right.
Authoring an instruction like, click the box to the right of allow backorders, hardcodes a spatial dependency right into the text. The technical writers must transition to intent-based syntax, enable the allow backorders parameter.
That syntax is entirely decoupled from the spatial geometry. Enable the parameter remains factually accurate whether the engineering team deploys a left-aligned checkbox, a right-aligned toggle switch, or a drop-down array.
Right. It survives future UI refactoring. It creates resilient documentation.
And the final phase is executing a staggered update cycle, right?
Yeah, you prioritize the high-velocity operational screens ledger entry, invoicing configurations, and you deprecate or update niche reporting manuals later as resources permit.
You know, it is functionally identical to executing a major urban infrastructure project. Well, think about an engineering firm that redesigns a critical highway interchange to optimize traffic flow and reduce collision vectors. The new interchange is mathematically superior. It conforms to all modern civil engineering standards. The moment the concrete cures and the new lanes open, the physical infrastructure is vastly improved.
Right, the road is better, but the informational infrastructure is destroyed.
Exactly. Every printed map, every localized guidebook, every legacy GPS routing algorithm in the world is instantly invalidated.
Oh, wow, yeah.
The physical bottleneck has been cleared, but the informational routing is now directing users to execute illegal U-turns into oncoming traffic.
That's a perfect analogy.
Yeah.
And updating those global routing databases, republishing the cartography, and retraining the drivers constitutes the true operational cost of the upgrade.
Yes.
Refactoring the .dfm layout properties in Delphi might consume a single sprint for an engineering pod. Reconciling the institutional knowledge and the localized documentation debt requires quarters, if not years, of sustained operational output.
It's wild to think about. We started this deep dive looking at the negative space between a text string and a 16 by 16 pixel Boolean control.
Just a tiny box. And mapping the blast radius of that physical coordinate reveals how tightly coupled all these disciplines are. The spatial positioning dictates the biomechanical efficiency of the interaction.
It determines whether the interface architecture can withstand the structural expansion of a German or Xhosa localization string.
It fundamentally alters the required syntax of the localization files, forcing verbs to collapse into nouns.
And it triggers massive organizational debt, rendering decades of localized technical documentation obsolete in a single commit. The architecture of our digital tools is an incredibly tense, highly interconnected ecosystem where a single pixel shift reverberates across human psychology and global linguistics.
In digital design, there really is no such thing as a small choice.
There isn't. I want to leave you with a final provocative thought to consider, sort of extrapolating on the foundational mechanics we've just mapped out today. We have spent this entire analysis dissecting the profound implications of moving a control from a right margin to a left margin on a two-dimensional plane.
Right, flat screens.
We're mapping the strict, unforgiving geometry of flat screens. But consider the architectural shift occurring right now as we transition towards spatial computing environments, augmented reality layers, and interfaces that are entirely mediated by voice-activated large language models.
Oh, wow. Yeah, because in a non-Euclidean digital environment like a pure voice interface or an unbounded spatial canvas in VR, the structural anchors of margins cease to exist entirely.
Exactly. When the bounding box of the physical monitor is completely removed, how will the underlying architecture of these invisible systems continue to shape our cognitive load, dictate our operational syntax, and govern our interactions? If a slight adjustment on an x-axis can rewrite the grammar of 105 languages and force the reauthoring of history, imagine the structural impact when the digital architecture escapes the screen entirely and becomes the air we operate in.
That is a terrifying and fascinating thought.
Keep that structural awareness active the next time your hand moves, automatically and invisibly, to execute a choice at the bottom of a form.